Chapter 2, Part 5, Baker's Percentage Conversion. This is the second method of scaling a recipe up or down. It is used primarily by bakers because it uses something called the baker's percentage. Baker's percentage assumes that flour is the most important ingredient in your formula. Because of this, flour is given a ratio of 100%. Every other ingredient is listed as a ratio of the flour. Let's take a look at this formula. It is actually the same one we did first for total yield conversion. We're just going to do it now using Baker's percentage. If you've paid attention, you'll notice that the order of ingredients has changed. Usually ingredients are listed in the order they're used. With Baker's percentage, the only difference is that the flour is always listed first. Looking at this, we see cake flour, we have 12 ounces, bitter chocolate, 12 ounces, butter, 1 pound 2 ounce or 14 ounces, sugar is 34 ounces, eggs are 10 ounces, and walnuts are 8 ounces. This adds up to 94, and our required yield is still 12 pounds 6 ounces or 198 ounces. So the first step is the same in both procedures. But look at those percentages. 150%, 283%, those don't make sense. How can you have more than 100%? You can because it's a ratio of the flour. So we have more butter and more sugar than flour in this recipe. That's kind of unusual. Most recipes using flour in baking do have flour as the highest ingredient, but not always. These are brownies. You have a lot of flour, you're going to end up with a dry brownie. So having a little bit more butter or sugar is not unusual in some recipes. It's just not as common. Step 2, determining the conversion factor. We're going to take the required quantity and divide it by the total percentage as a decimal. If you ask any math teacher, should you ever add up a column of percentages, and they're going to tell you no. However, we do. So look at the column of percentages. You'll see it adds up to 783%. We're going to change that to a decimal. So now it's 7.83. So to get the conversion factor, we're going to divide 198 by 7.83. That gives us 25.29. When the number is this large, and in most bakers' percentage conversions they are, we round to the whole number. In total yield, we left 2 decimal places. We had 2.11. Here, though, we're going to round this to the whole number and use 25 as our conversion factor. We're winding down to the end here before we get to the next section, that is. So now we are ready to calculate our new quantity. And we do that by multiplying the percentage times the conversion factor, and that gives us our required quantity. Notice we do not multiply the original quantity. We look at the percentages. First thing we need to do, though, is make it a decimal. Move your decimal point 2 places to the left, actually. I don't know why that says right. Anyway, I'll change that. So 100% becomes 1. 1 times 25 equals 25. If you look at the little red dots, you'll see that 150% becomes 1.5, 283% becomes 2.83, 83% becomes 0.83, 67% becomes 0.67. So you will continue to multiply across each row and get your new total ounces. And here we have your new required quantities. 25 ounces, 25 ounces, 38 ounces, 71 ounces, 21 ounces, 17 ounces. Convert those back to pounds and ounces. We've already done that, so you should know how to do that. When I check my cross-footing, that column added to 197, my row added to 198. That difference is negligible, so it's fine. Here we are with the grams again. Step 1, skip it. It's already a common unit. Step 2, conversion factor. Dividing the required quantity by the total percentage as a decimal. Required quantity is 5,613. The decimal, or the percentage rather, as a decimal is 7.83. That equals 717, and that is your conversion factor. Multiply the percentages as decimals against the conversion factor. We have 1 times 717 equals 717 for the first two ingredients. 1.5 times 717 equals 1,076. 2.83 times 717 equals 2,029. 0.83 times 717 equals 595. 0.67 times 717 equals 480. That adds up to 5614. Our original number was 5613. The difference is negligible. If we did need to scale this to kilograms, it would be 5.6. Here's the part I like best about Baker's percentage. All you need to know is how much flour a recipe has, and you can figure out how much you need of the rest of the ingredients pretty quickly as well. So we have 12 ounces of flour. With those percentages as a ratio, we know that we need 150% butter to flour. So I'm going to multiply 1.5 times 12. My percentage as a decimal is 1.5. My 12 is 12 ounces of flour. That tells me I'm going to need 18 ounces of butter. Here's one more line. 2.83 times 12 equals 34 ounces. See how quickly you can figure this out? What's best about knowing this, though, is let's say you decide you're going to make these brownies at home. And you get your flour out, and you don't have 12 ounces of flour. You only have 10 ounces of flour. You jot down 10 ounces, 100%. You've got the rest of your ratios, and you can adjust all of the ingredients so you can still make those brownies without having to run to the grocery store to buy more flour. This wraps up Baker's percentage conversion. We have one more video coming for one more handout, and we will finally be through Chapter 2. Good luck getting the rest of these problems solved. Work through the ones that I demonstrated and make sure that you're getting those same numbers. Thanks. See you later.